Good day, students. So here we are in topic 1, lesson 6, reflection. So just to clarify what we're going to be doing for this lesson, we're going to be looking at how reflections are represented in the coordinate plane. We're going to also describe a reflection and how that looks as a function rule. And then lastly, we're going to look at a reflection in terms of the perpendicular lines and line segments. So the first thing we have to ask ourselves is, what is the similarity and differences between the image and pre-image of a reflection? Well, we all know that reflections are rigid transformations. So it's not going to change the shape or size of that reflection. However, it does change the direction in which the reflection is turned to. So we know that every time we reflect a figure, it's going to reverse the figure or turn it or orientate it differently from the pre-image. The second question we should be asking ourselves is, what's the similarities and differences between reflecting over an axis and then reflecting over a linear function? Well, we know that the similarity is that it will always be a rigid transformation. The size and shape will never change. However, when we reflect over an axis, it's going to be a mirrored transformation. So think of folding the two images onto each other like on a sheet of paper. But if we reflect over a linear function, that actually changes the orientation or the direction in which the pre-image originally was turned. Okay, so let's look at example 1. It says reflect the figure with the given vertices across the given line using the rules for reflection. So the rule that's been given to us is y equals x. Okay, so if we look at our little cheat sheet at the bottom here where it says rules for reflection on a coordinate plane, we see that y equals x, sorry, wrong one. The y equals x line of reflection tells me that I'm going to take my coordinate points of my pre-image and flip them. So here for the rule, we can write that my new coordinate points should be y comma x. So that means I'm going to take all these points that I have here, D, E, F, and G, and first plot them on our coordinate plane. So we have 2, 0 here for D. We have 2, 2 here for E. We have 5, 2 here for F. And then G is 5, 1. And I'm going to take all these points that I have in my coordinate plane and apply the rule by flipping it. So these are my pre-image points. So if I take D, D is 2, 0. So that means D prime, when I flip it, should be 0, 2. If I have E, E is 2, 2. Well, that has the same X and Y ordered pair. So that means it's going to be the same 2, 2. F is 5, 2. So when I flip those, oops, that's supposed to be F. When I flip F for F prime, that's going to be 2, 5. And then lastly with G is 5, 1. So G prime is going to be 1, 5. So I'm going to take all these points that I just applied the rule to and then go ahead and graph them in the coordinate plane. So I have D prime, which is 0, 2, so that's going to be here. E prime, as you can see, is the same point, so that doesn't change. F prime is 2, 5, so that's up here. And then G prime is 1, 5, and that's here. So we're going to take all these points and do the same thing we just did with our pre-image and connect them for our image. And let me go ahead and highlight this in so you can see what our image looks like. So that is our image right here for D prime, E prime, F prime, and G prime. All right, so we have our image, right? That's our image. But now you see that it's been reflected over this line y equals x. But what does that line y equals x actually look like? Well, if we think back to algebra 1, the y equals x line is actually the parent function of all linear functions. So that means it is a positive slope of 1 that goes through the origin, because that origin is the y-intercept to that function. So our y equals x line looks something like this, going through these points. That is our line of reflection. And remember at the beginning when I stated if I have a line of reflection that is a linear function, it changes the orientation or the direction of the pre-image to the image. So as we see, the pre-image, it looks like it's pointing to the right. And here at the image, it's now facing upward. So as we can see, when we reflect over any linear function, it changes the direction of the figure. Now let's look at example 2. Example 2 says, given the pre-image and image, find the reflection rule for the transformation. So here, this question asks us something a little bit different. It asks us now to find the reflection rule given the pre-image and image. So if I'm given the pre-image and image, I have to think back to what is the definition of what a reflection is. Well, a reflection says that any point that I have in my pre-image is equally distant to the reflection line as the corresponding point in my image. So if I have n here in my pre-image, that means n prime has some fixed distance, and that fixed distance is 2. And then the midpoint is located, and let me make that a little bit thicker so you guys can see. The midpoint is the distance that's equally distant from n and n prime. So we can see that for all the points in the pre-image. So from M to M prime, there's a fixed distance of 2, and the midpoint of that distance is located here. So from M to the midpoint is 1 unit, and from M prime to the midpoint is 1 unit. And that is also true for here, P. P in the pre-image is a fixed distance away from P prime in the image, and we see that distance to be 1, 2, 3, 4, 5, 6 units. And the midpoint between 6 units would be 3 units. So let me make that thicker. So that tells me that midpoint should be somewhere there. I have 3 units away from the midpoint from P and 3 units away from the midpoint of P prime. So how do I find my line of reflection, my rule? Well, I take all my midpoints and I just simply draw a line straight down through those midpoints. And I can see that that line that's been created through that midpoint is in fact my line of reflection. Well, how do I determine what my line of reflection is? Well, I look at this line and I see that it is the same line as my y-axis. So that means that my line of reflection is indeed the y-axis. And if I come back here to my little cheat sheet here, it tells me that anytime that I am reflecting across the y-axis, I take my points and I do a little change to it. The rule tells me for the line of reflection for the y-axis to take the opposite sign of my x coordinate and then keep my y coordinate the same. So that is my rule for this particular transformation. Now, how can I be sure that this is the correct rule? Well, I can just look at the points. If I look at point P in my pre-image, the point P is 3, 3. Point P prime, which is the corresponding point, is -3, 3. As you can see, the rule holds up because it says here for my x I had +3, and here for my y I had a -3. And that should be true for all the points that are corresponding from my pre-image to my image. So for n, I have 1, 4, and then for n prime, I have -1, 4. For m, I have 1, 1, and then for m prime, oh sorry, that's not 1, 1, that's 1, 2. My mistake. So that's 1, 2. And then for m prime, I have -1, 2. As you can see, for all of these other points, from the pre-image to the corresponding image, I have the axes have all changed signs. All right, so let's look at example 3, part A. So it says graph the image of the figure using the transformation given. So here they are giving us the rule. The rule says to reflect across the y equals -2 line. So before we can actually reflect this figure, we have to figure out what the y equals -2, what the y equals -2 line looks like. So it says y equals a constant. So that tells me that I'm going to be creating some line that is going to intersect the y-axis. And we know it's going to intersect at the -2 point. So starting from the origin, I know I'm going down 2 units, and that's where -2 is. So that means that my line is going to be crossing horizontally here at -2. So this is my line, and let's label it y equals -2. So now that I have my reflection line, now I can just apply the rule or apply the definition of what a reflection is. I take every point in my pre-image, and that point, all those points in my pre-image are equally distant from the reflection line as the corresponding points in my image are. So if I start with Q, Q is 2 units away from the reflection line. So if Q is 2 units, and there you go, 2 units away from the reflection line, that means Q prime is also, sorry, not sub, prime is also going to be 2 units away from the reflection line. The same for every point in the pre-image. X is 3 units away, 3 units away from the reflection line. So that means X prime is going to be 3 units away. E is 1 unit away, so that means E prime is also going to be 1 unit away. Now the interesting thing about this problem is that I is actually on the reflection line. Anytime that you have a point on the reflection line, then the corresponding point of the image is going to be equal to the same point as the pre-image. So any point on the reflection line is going to be the same as the point in the image, and that point will also be on the reflection line. So now that I have all 4 of my points, I can go ahead and connect the vertices. And let's go ahead and highlight that in so you guys can see the difference. Here is my image that has been reflected over the y equals -2 line. There's my image. So as you can see, you can also determine now that because y equals -2 is a linear function, when we reflect over a linear function, it changes the direction of the figure. So here you see that the direction of the pre-image is kind of looking downward. Here in my image, the figure has now been turned upward. So once again, we can see that when we are reflecting over a linear function, it changes the direction of the image. All right, part B. So part B, same type of problem. The only difference is we are looking at a different rule. This rule tells us that we are reflecting across the y equals -3 line. So once again, if it says x equals -3. So if we're reflecting over x equals -3, that tells us that I'm looking at something that crosses the x-axis at -3, some line that crosses the x-axis at -3. So where is that located? Well, I look from the origin and count to the left, 1, 2, 3, and I find -3 to be this point here. So that means that this line right here is going to cross the x-axis vertically. And this is my line of reflection. So this is a little bit different from the other problems because our line of reflection is actually located through our pre-image. But does that change anything? Well, no. The definition of reflection still holds to be true. Any point in my pre-image is going to be equidistant to the reflection line as the corresponding points to my image. So I have W here is 1 unit away from the reflection line, and let's label that line. We have it x equals -3. So from the line x equals -3, we have W being 1 unit, so that means W prime is going to be 1 unit. We have S here is 1 unit away from the reflection line, so S prime is 1 unit away. P is 1 unit away from the reflection line, so P prime is 1 unit away as well. And then we have I is 2 units away, so I prime is also 2 units away. So now that I have my points, I can just go ahead and connect my vertices to create the image that I have here for my transformation. And let me go ahead and shade that in so you guys can see. So this is my image. Once again, we have reflected over a linear function. So because we reflected over a linear function, we see that the orientation, the direction, has changed. So my pre-image was pointed kind of like to the right, and now you see that my image is now turned or flipped to the left. So this is what happens when you are reflecting across a linear function. All right, example 4. So example 4 says, now we're going to write a rule to describe each transformation. So the difference between example 4 and example 3 is now we're trying to find the rule. Example 3, they gave us the rule. Now we're trying to find what that rule is. But does that change how we approach this problem? No, we are still going to use the definition of what a reflection is. So that means I'm looking at any point from my pre-image. So let's look at point K, and I'm knowing that K and K prime has some fixed distance, and that distance between K and K prime has a midpoint. So the distance between K and K prime is 6. So I know that that midpoint is going to be equally distant from K and K prime. So from K to the midpoint is 3, and from K prime to the midpoint is also 3. And that is true for every point from the pre-image to the image. So if I look at F, the distance between F and F prime is 2. So the midpoint is going to be here. From F prime to the midpoint is 1. F to the midpoint is also 1. Same thing is true from V prime to V. That distance is 4. So that means that the midpoint is going to be here at 2. And then the same is true for J and J prime. That distance is 2, and the midpoint's already calculated from V to V prime, which is 1. So let's go ahead and connect the midpoints. If I connect the midpoints, this is the line that's created. Now we just have to determine now, how do we find the midpoint, or how do we find the equation of the line to write my rule? So if I notice that this line is intersecting the y-axis, and then we have to determine at what point is this line intersecting the y-axis. Well, this point that is being intersected is this point right here, and that is point 0, 2. So if I'm having my line intersect at point 0, 2 along my y-axis, that means my reflection line is at y equals 2. Now let's look at example 4, part B. Again, we are writing a rule. So we're trying to write a rule to describe the transformation that's given. So this one is very interesting because if you notice, you already have two sets of points that are the same. We have points D and D prime, which are here. Let me use a different color, something that's a little bit brighter that you guys can see. So we have D and D prime here, and we have B and V prime here. I see that D and D prime and V and V prime share the same point. So remember, if you notice 2 points, image and pre-image, that are the same points, and you know those 2 points are already on the line of reflection. So that means a line of reflection has already been created. So if we want to identify that line of reflection, we can see the pattern that's taken place. So I can already mark some points. Let me make that a little bit lighter. I can already mark some points that I see that could possibly be on the line of reflection. I'm going to highlight those points here. And I see that it's creating this line here. So let me go ahead and highlight this line that I see is created. And for right now, we can say this could be the possible line of reflection, but we always want to make sure that it actually is the line of reflection. But we've already verified for V and V prime and D prime that these two sets of points are actually on the line of reflection. But now we have to look at 2 other points. We have to look at U and U prime, and we have to look at T and T prime and make sure that their midpoint is actually on this line of reflection that we've just created. Well, how can we determine that? Well, let's think about the definition of a reflection again. Remember, U is going to be equally distant from the line of reflection as is U prime. So how can I determine the midpoint of these 2 points? Well, first I have to determine the points. So U I see is -1, -1, and U prime I see is 1, 1. How do I determine the midpoint between 2 points? Well, I use what is called the midpoint formula, which says I take the x's, add them together, divided by 2, and I take the y's, add those together, and divided by 2, and that gives me the point that's directly in the middle. So before we do that, we want to label our points x1, y1, x2, y2, and then we just plug it in. And we're going to plug this in for U and U prime. So my x coordinates say I have x1, which is -1, x2, which is +1. So a negative 1 plus a +1 gives me 0. And we divide that by 2. And my y's, I have a -1 here and a +1 here. So -1 plus +1 gives me 0 again. So that's 0. And then 0 divided by 2 is just going to give me 0. So that's 0, 0. That's at the origin. Well, let's confirm. Between U and U prime, let me move that out the way. So I have here 0, 0. Well, is 0, 0 on the line of reflection? Well, yes, it is. So because 0, 0 is on the line of reflection, then I know that so far I have these 2 points, U and U prime, as being equally distant from the line of reflection. Now we just have to confirm that with T and T prime. Okay, T and T prime. So before we do that, let's identify what those points are. So T I have as -1, 0, and then T prime I have as 0, 1. And let's go ahead and label those. That's x1, y1, x2, y2. And when I plug that in, so my x's, I have -1 plus 0. Well, that gives me -1, and then divide that by 2. And then my y's, 0 plus 1. So 0 plus 1 is just 1, and I divide that by 2. And then I already have my points, -1/2, 1/2. And where is that? So if I start from the origin, I go to the left 1/2, and then up 1/2, I'm going to end up somewhere around there. And is that point in between T and T prime? Well, yes. And is that point on the line of reflection? Well, yes, that point is on the line of reflection. So I can say for sure, these 2 points, these 2 pairs of points, U and U prime and T prime is on the line of reflection. But the question didn't ask me to verify if those points were on the line of reflection. The question asked me to determine what the rule is. So I have to determine what what the equation of this line is. So let's think way back to Algebra 1. So let me clear these off, so that way we don't have so much stuff in our way. So we've identified, yep, everything is on the line of reflection, everything's copacetic, we're good to go. Let's go back to Algebra 1. If I have a line going through the origin, if it's intersecting at the origin, then I can say, using my equation of a linear function, my general rule for the equation of a linear function, that the b, which is my y-intercept, is 0 because it's going through the origin. Now the only thing I have to determine is what is the slope. Well, we know, reading a graph from left to right, this graph is decreasing. Left to right is going down, so that means that my slope needs to be negative, right? I see that my slope is negative and it's following in a pattern. So if I read this graph from left to right, I see that it's decreasing by 1 and then increasing by 1. So I'm going down 1 and then over 1, down 1, over 1, down 1, over 1. So remember, slope is rise over run. So in this case, I'm falling 1 and then I'm running 1. So that means my slope is -1. If my slope is -1, then this is the equation that I have, but we can clean this up. We're mathematicians. So I don't have to represent my y-intercept as 0. And if I have anything being multiplied by 1, that's just itself. So I can clean this up and say that the equation of this line is y equals -x. So the reflection line of this transformation is going to be y equals x. All right, ladies and gentlemen, so that is wrapping up lesson 6. If you haven't done so already, you need to go to your lesson 6 vocabulary, which can be found up in your warm-up activity. Watch the videos. There's a wealth of information there. Quick reminders with those videos as far as what are the vocabulary terms that you should know about reflections. Remember again, if you have any questions, feel free to reach out and contact me. See you later, guys. Have a great day.